we're going to talk about special triangles. They're right angles, and there's actually two of them. So make sure I get this right. 1, 2, 3, 4, 5. 1, 2, 3, 4. Just so it looks somewhat to scale. We'll do that one there, and then we'll do our other one. Similar, a little different. Okay. They're both right angle triangles, which is nice. One of them is an isosceles triangle. So if it's a right angle triangle and it's isosceles, that means the other two angles must be, pardon me, it must be 45 degrees. Okay. Have you guys talked about radians? Where a radian is? Not particularly? Okay, we'll just stick with degrees. So we have two 45-degree angles, and then the sides have a ratio. And the ratio is this, 1, 1, root 2. And that works fine, because if you remember Pythagorean's theorem is a squared plus b squared is equal to c squared. Okay. The a and the b are the legs of the triangle, which happen to be these, just the sides that aren't the hypotenuse. Okay. So if we said 1 squared plus 1 squared is equal to c squared, 1 squared and 1 squared are both 1. So we have 1 plus 1, the classic math fact, which is 2. And then when we go to isolate c, we would square root both sides, and we end up with root 2 as the hypotenuse. Okay, so what's neat is this one's a relatively easy version of it to remember. And you actually tend to end up wanting to memorize these because there's a lot you can do with just these little facts here. Okay, the other special triangle is a little trickier. You have this relationship. This one is 60 degrees, and this one is 30 degrees. You guys give your stuff, okay? Thank you. This one here, similar Pythagorean theorem, but this fact is a little easier. It's the fact of 1, 2, 3. So this side length is 1. The hypotenuse happens to be 2, and the other side here is root 3. So we just got to kind of remember that 3 is actually not the largest value here. Always when you look at a triangle, the hypotenuse, which is the side opposite of the 90 degrees, is always the longest side. Mm-hmm. Okay, so root 2 is bigger than 1. That makes sense. 1 happens to be the smallest side. And a way of remembering this triangle is because we have 30 and 60, and it's very common to mix up the lengths of these legs here. Maybe you think root 3 is over here and 1's here. But 30 degrees opening, think of it like the mouth of an alligator or something like that. If it's opening 30 degrees, it's not very large. But if it's opening 60 degrees, that's bigger than 30 degrees. And because that's bigger, root 3 is larger than 1. Okay, so we just, 1 is the smallest, root 3 is the next biggest, and then 2 is the largest side of that. And if you want, we could do the exact same thing with Pythagorean's theorem. We could say 1 squared plus root 3 squared is equal to c squared. This ends up being 1 plus root 3 squared is actually 3. We end up with 4 is equal to c squared, and when we root each side, we get 2. Right? And we could say plus or minus, but we're measuring in our reality here, right? So it would only be positive in terms of this one.
What are like the point of ratio? Like, is that
So-
how long it is?
Yeah, so this is essentially how long one of the sides are.
Okay.
Now, one of the other facts they would have done with you previously is something called similar triangles. So similar triangles is where you can make any size triangle with the internal degrees being the same, as long as we multiply the sides of this triangle by the same scale factor. So an example of this, is which will commonly be done, is they might want to find a triangle, which will kind of lead us into our unit circle here actually, so I might as well do it now. Is we want scale factors of those two triangles. I'm just going to close that door. Want scale factors of these two triangles, but we want the hypotenuse to be 1. So we have 1 as a value for both of these hypotenuses. So we still have the right angle triangles, and we still have 45 degrees for this isosceles one, and we still have 60 and 30. Okay, this one's solvable without doing the scale factor. This one isn't. We have 3 different sides. We don't have enough information. But because we know these triangles above, my question then becomes, okay, I'm going to scale, and I want my hypotenuse, which is currently root 2, to be equal to 1. So what can I divide or multiply by to turn this into 1? And it turns out, if you just divide any number by itself, so we divide by root 2, Root 2 divided by root 2 is 1.
Mhm.
So for a scale factor of a similar triangle, whatever you do to one side, you just got to do it to the rest of the sides. So that becomes, well, what is 1 divided by root 2? Well, it's some number, but we're just going to leave it as a radical, okay? And because this is isosceles, that means the other one's the exact same length. We can put it through Pythagorean's theorem. You'll end up with the exact same values here, that it works out. But this is a very common one because this one fits inside of our unit circle. It is 1 unit long, the radius, okay?
Yeah.
Same idea here. We're going to fit this one in. Now, if you remember from our other, we are taking this number 2. It's a little large. We got to bring it down to 1. Well, same idea. We're going to divide by 2. And whatever these legs are, we divide by 2. Well, that one leg was 1. So when we divide it by 2, it's a half. The other one's root 3. So we just put root 3 over 2. We leave it as a radical. Both of these are sufficient in terms of memorizing. Knowing one of them allows you to know all of them by just scale factors. Most commonly remembered are these two up here, the 1, 1, 2, and then the 1, 2, 3 version are the most common ones to remember.